after lunch. Little sleepy? Me too. Okay. Yeah, it's not easy. Okay. After food, just come and listen to boring lecture is not easy. Okay. And in addition to, they call salt into injury. So this part of the lecture is kind of boring.
Only for today, so tomorrow both the lectures are in the morning. And mine is there in the afternoon.
No, not because I'm saying that this is actually a lot of computer science stuff. How many of you have computer science background? Okay, but they're not too hardcore computer science, more system side. Okay, so you can definitely catch up that. Okay, but definitely these are the stuff for IoTs. The thing is, IoT is not something deeply you can say. Oh, this is I call that actually is a why is a. Do you remember that story? 7 blind people went to see the elephant. Right, right. They just say these things. Right. So now, IoT is for everybody. You will find experts from computer science, computer engineering, and what not. Health science, okay, mathematics. They're all engaged. They have a pie of the economy, that comes through this, and multimedia. So it's a amalgam of many expertise over there. Anyway, I was just taking some time so that more people can join. Okay, so ready? We can start then? Okay. Yeah, if you look at the schedule, the title of the lecture 2 was something different, because the second part of the lecture was entirely for that second lecture, but we could not complete the software architecture OS for the first one. So what I did, we put them together quickly and take out some of the slides. I would have skipped anyway those things later. So put actually this lecture for 1 hour. Okay? SOS, not that SOS, no hurry. Okay? School SOS, not hot SOS. Okay? So we'll talk about software, in particular operating systems for the IoTs. And it's not general operating system that we talk typically, but it's much more blended towards IoT. And more important thing is what would be interest to many of you, that many people would like to be developing a product, okay, product development. And many business, even many students, many application engineers, they can call developer, right? Application developer and API developer, call it. And many people, they change their role from one to another to do business or bring a new innovation in the product. So how the product development takes place? What to need? Is it directly for industry-oriented people? And fortunately, the academia also, they have to develop. So it is good for both. You'll be hearing words like methodology. You'll be hearing words like framework, platform, tools. They seems to be similar, right? But they're not similar. They're pretty different. So this is the time we catch them with their definition and the relation between them. Okay? There are many slides I took out to see the features in all those things. I can always add that and give it to you for reading later. But for this 1 hour, let's stick to, maybe I may take 1 or 10, 15 minutes, maybe more if necessary. We'll see how it goes. Okay? So topic is IoT operating systems and product development. The second part is about how you can develop a product out of for IoT. IoT directed product development. That way you can innovate new products, you can be part of industry selling your product, or you can design new things. Agenda is, as I told, these are references, so you can use these references later. Okay? Coming to software architecture for IoT, okay? you know that IoT is not a small entity. It can be tiny. It could be worldwide. Just like now, Lord Hanuman, he can shrink to a small ant and expand himself to a big mountain. IoT situations like that. It can be a single system or many, many systems, subsystems. Okay? So we call it IoT makes the world programmable. How? In the world you put IoTs everywhere, you program it, world is programmable. As simple as that, okay? Now, the software typically for IoT, it embeds many resources, starting from single sensor, couple of sensors, actuators at the very edge, and all the way to the cloud where you have servers, platforms, designer, everything is there. So software architecture has to mint, stretch like elastic, okay, everywhere. Now, a wide spectrum of software architecture, okay, option exists for various devices. That actually makes the IoT, using IoT, designing around IoT hard. So we have to know various device properties, device features, device capability, and OS software requirements. It could be a simple design, could be limited sensing devices, could be selective sensor devices, and also we'll talk about features, okay, which will follow in the next couple of slides. Okay? Then some IoT devices can have a simple OS versus a full-fledged OS. And we also look into from developer perspective. So software architecture for IoT is really complex, and people typically underestimate that, and they say, okay, I know everything, without knowing that a huge part of IoT is neglected, and that might trouble the users as well as designers. So let's start with the operating system. Why we need operating system and how much you need. Two things. Do we need operating systems and where do we need it? And how much is enough for that? We'll address that to begin with. Okay? To ensure the accuracy of IoT, okay, your device should be able to communicate with the rest of the world. Okay? Veracity means accuracy. Okay? And the OS is the entity who hides all those intricacies, all the details. It hides it. Okay? So if you're an OS designer, you put OS so that when the programming takes place, interaction takes place, communication takes place, protocol is working, OS handles it. It takes big part of your work. Okay? So that's the advantage of having OS in the system. Okay? OS is a great secretary. It takes a lot of low-hanging loads from you and do it. Okay? And depending on devices, could be small device, could be many, many processors, big processors. You see Android is used, you have Raspberry Pi is used, sometimes even your mobile phone processor, which is half a Cray supercomputer, old supercomputers capability is used. So the OS must be flexible like elastic again to be placed there. The another thing is scheduling is important because there are so many tasks to be done. Okay? Multi-threading, all those things has to be handled by the OS. Because you don't want any simple application app will not able to handle that. Okay? Now, the key requirements for IoT OS could be having a small memory footprint. Because typically always you are measured in terms of spending memory and energy. Okay? At the same time, you expect a real-time convenience. So typically, your OS can be small, which can be retained in a small memory footprint, small memory area, and energy efficient, and hardware agnostic operations. Means sometimes necessary, it will ignore the hardware and work. Okay? Then also it will provide some kind of security. It also helps coordinating networking protocols. Then help in when to store data, when to release data, then reliable communication at the same time, and do device management. Do you see? All these tasks are not easy. And any app developer, if you want to do that, it's a painful. Sometimes they can go wrong. Therefore, the OS is the one who takes the data details from you and manages everything. Okay? So we need adequate operating system. Adequate is different meaning. Yes, how much is adequate? A small processor may be needing small things, a big need big things. So it's kind of depending on the scenarios. Now, architectural types and features of OS for IoTs. Okay? The three types of OS we'll look into: monolithic, microkernel, virtual architecture. Now, when you start with thinking kernel, have you heard about word kernel? Kernel is the minimum basic OS requirements, OS statements. You need a kernel to drive anything. Kernel is a unique bundle of programs, for system level programs you call it, okay? And which is enough to drive everything, touch everything, check everything. Kernel, core, same as core software, OS software. Now, the monolithic means you combine the OS and application together. So you cannot distinguish them. And typically use that for the IoT, they are small in size. The scope is a little less. Okay, reduce scope, reduce applications, small IoTs, few members in the IoT areas, few set of services. There you can use monolithic because it spends less energy. It costs also less to develop. That's why. The second one is microkernel. It provides minimum functionality in the kernel. It's called microkernel. It is bigger than monolithic, but not full-fledged OS. And minimum functionality is good enough as adequate. And the application and OS are built as a set of interacting modules. In monolithic, they are together, one entity. Here they are separate, but they interact with each other. Okay? Whereas virtual architecture, okay, it works on the principle of virtual machines. Have you heard about that? I'm sure many of you have not actually, it's not late, it's desirable that you know those things. Okay? Your world is virtual, everything is virtual now. Okay? So, as IoT at the same time. So virtual architectures are based on virtual machines. By the way, virtual machine, virtual architecture are not same thing, but they are very close to each other. Okay? What's a virtual machine? It's a technology, it's a software. You can implement a processor as a virtual machine. Okay? And virtualization is the technique behind that. Virtualization could be plural. Virtual machine could be singular in some sense. Okay? So distinguish those things. One is technology, other one is a infrastructure, you can say. Okay? Now, virtual architecture works on the principle of virtual machine, which is actually, you can export to user programs also sometime. We'll talk about that when you go to container type. And quite often, many people will not distinguish what virtual or software architecture is doing versus the hardware is doing, as if you're using hardware. Okay? Now, IoTs require OS, okay, have small kernel size, so that they don't, that's adequate, they don't want to unnecessarily load the environment or ecosystem. Then they use small memory footprint. Again, more memory means more energy, more space, and IoT hates that. Okay? And reliable, then easy extension of kernel to boost the flexibility. So as you needed, you can go from here to here and here to there. So in summary, this slide says, very tiny system, you can use a monolithic operating system where OS and apps are together, single entity, you cannot take it out. Microkernel, they are different entity, they talk between themselves, is bigger than this. Virtual architecture is much bigger than this. Okay? Now, what are the OS options? There are so many options, 7 options. Okay? No OS architecture. You will find applications by IoT, don't need OS. We'll talk about that quick. Then RTOS, real-time OS architecture. Then language runtime architecture. Okay? Then full OS architecture, app OS architecture, server OS architecture, then container OS architecture, which is most modern. Okay? Let's take one slide on each and try to define them, try to say the pros and cons and things like that, what they need, what they don't need. Okay? No OS architecture. Okay? Small applications like monitoring your home or any system, any place, any environment, your thermostat, temperature thermostat, even simple light bulbs on off, scheduling that, reducing and enhancing the intensity, okay, of the light. And today you must be seeing that you can buy actually electric plugs and which you can control on off and scheduling too for many purposes. Okay, breeding the eggs, okay, chicken eggs, kind of breeding chickens. Then there are so many things. Even aquarium, we can control those lights and stuff with a plug actually. Okay, there you don't need a full-fledged or any OS. A simple thing no OS can work. I'm sorry? Yeah, but they usually to work. That was the long time back. Now, most of the time you buy things, they provide the app actually. So when you buy this kind of bulb, smart bulb, it comes with the app. And if it's proprietary, they provide the app itself. It comes free actually. Yes, that's correct. That's a good reason also, that way they can monitor how things are going. But yeah, but probably it will be in a few years they have to standardize that. Yeah, that's the kind of everything new technology comes up. They want their own way. They're forced to standardize, just like communications. All those connecting to your computer now. One time they're all different, just like your bulbs. But then they sat together, the alliances they built up, and they decided to follow this one, and everyone agrees into that, then everything is smooth. Your IEEE connections, interconnects, same thing. Same thing, all this will be coming off. I know, because when you buy, suppose I am buying the PT electrical products, I don't buy from Kasaba. Okay, they have two different things. So you're hung to that. But time will come, you can buy anywhere, they all go into same melting pot. Okay? Then, yeah, so they do not need OS or an application platform. But they do need application platform to control by the proprietary things. But in general, they're not supposed to. Okay? So we are talking about the best ideal scenario versus what is happening. Then device-specific software are developed in-house. That's what we're telling. Okay? They build it and sell it. Then firmware are being updated also online. Okay? If you don't follow any term, don't hesitate to ask. Okay? So firmware. Firmware is, if you have a program, you can put that into flash drive, or flash memory rather, and it's like it's neither hardware nor software. Okay? That's called firmware. Sometimes we store kernel, OS into flash memory. That's firmware. And software is when you can change things. And firmware you change when you need to change for update and things like that. Okay? Then this system with the no OS architecture, they need very small amount of memory, and the battery requirement is also very low. So you set the battery, it will go many, many years. Okay, depending on the device. Okay, some devices don't need battery, and if they need battery, it goes many years, 10 years, things like that. Okay, and they use protocol like MQTT and co-op. We will discuss this later. Okay. Oh, okay. The RTOS architecture is definitely richer with a more set of sensors around that, and you need real-time operating system for that, and most likely they will be open source, and sometimes they start with proprietary too, but RTOS could be open source as well as proprietary. Then the APIs are also being supported, but there are two things actually. Watch it carefully. We say here, open source commercial real-time OS provides toolkits and API to support second-party software development. Okay, underline that. Then you also read here, they do not provide public third-party developer APIs. So there are 2 parties and 3 parties. What is that? Okay. Second party means if I am the product developer or a product seller, I sell you, we are 2 parties. There is no third parties coming and doing anything. The third party could be public party, could be another seller. I can sell a product, you don't have to depend on me for the software. Third person can provide that. Much broader in sense. Is that clear? So 2 party is I sell you a product, we are 2 parties. I provide the support to develop the app. Third party, nobody else can do that. Okay? When it's open source, almost all open source are third party. Is that clear now? Okay. Then they need actually more memory compared to the NoS architecture. Okay? And the devices are also battery operated and use more battery or energy compared to other one. Okay? That's another one called language runtime architecture. I'm sure many of you not in computer science area will not heard about these things, but it's a good time to know them. Okay? Language runtime architecture. Now here, some IoT development boards when you buy, okay, they come with specific built-in language runtime. They're all, only specific has been used to do API development. Why they do that? Because it's easier to do that. A particular language has been very much aligned with the development ecosystem. Okay. At the happen often? Not really. Sometimes it's kind of slowly they might go away, but at this point of time, you can see some of the products in this area. Some of the applications are very widely used. These are pretty widely used actually. Okay. Now, they have a specific built-in language runtime, and also they use virtual machines. Okay. They are more capable than NoOS and RTOS solutions, and they always support third party. That means they are more into mainstream compared to the previous one. Okay. And applications run in sandbox so that it provides added security. You know, sandbox, when I read sandbox reminds me something. You know, you have seen those police chuck, you know, these places, they put a sandbox, they hide behind it. Have you seen that? You have seen, in India there are more than anywhere else. They put a couple of sandboxes over there, they're just hiding and keeping the guns over there, right? It's protection. So the same sandbox concept is being here. You will see that. Applications are on a sandbox that provides limited access to underlying platform features. That means everyone cannot go there. It's limited to only few applications can use that. Okay? And OS being a critical entity to control everything, if you get hold of OS, everything is smashed. That's why the sandbox approach has been maintained there. Okay? And obviously their memory requirement is a little more, not too much difference though. Next is full OS architecture. So it's about everything, a lot of things. And we are used to this. Okay, we love this because you have Linux. You can use Linux to implement a lot of capability that will support it. They're getting bored now. Are you okay? Are you, okay. Okay. Oh, it's okay. Okay. Sorry. What I'm telling you here is, if you have come across Raspberry Pi 3, 4, 5, whatever may be, the full OS is there in those Pi. They consume more power. Their memory requirement up to 1 gigabytes. Okay? Okay? And they always support third-party applications and services without any trouble. And they can support full stack of OS to developed. Obviously, all that costs energy and memory. Okay? Another one is called App OS architecture. Okay? Now, if you are using Apple Watch, there is a Watch OS. It's different from regular Apple OS. Apple uses a OS for the Apple iPhone separately compared to the OS meant for Apple Watch. It's thin client compared to the your phone level. Okay? Now, compared to mobile phone, which is essentially in case of Apple, it is a iPhone. In case of Android, it's called Android Wear. Android Wear is a OS like Apple Watch OS. So Apple, and this day by day things are changing. In fact, 2-3 years back, you are able to do limited things in watch, but you are able to do a lot of things now in your watch, Apple Watch. Same as also Android Wear. Sometimes I feel Android Wear is much more advanced compared to Apple. There are more users in this Android, less expensive, and a lot of variety things are there also. Okay. Now, if you look at the hardware processor capability of Watch OS, it is same as the phone 5 years old back. Okay. Now, they need more memory. Okay. They also operate at very high frequency. When a device is using this kind of frequency, using this kind of memory, their battery will go in 24 hours. Okay? But App OS architecture is essentially those class. Then server OS architecture, typical server that you know, you're familiar with before. You can have, and what you do here actually, many of you will be using that. The way the IoT has been emerging as a larger devices, more capable devices, more computing power, more and more you'll find server level capability, which means IoT can work as a server. My lab actually students do that, undergrad students do, every year they use these things, okay? Because they use a Raspberry Pi so that they can collect data, data will be uploaded to a server, they can put a back-end server, okay? And they will be putting a lot of application onto that, okay? At the same time, to do that, they'll be using, have you heard this thing? Node.js. This is actually, in the IoT device, if you want to create a web page for your IoT, you need this. Do you have any project, a lab written Node.js? We have a red node, but I thought, well, it's not difficult actually, yeah. Anybody can do these things. They have been pretty easy. It's called a web server. You can host a web server using this. Yes, yeah, this is very common actually. You can do that. That's lots. Beautiful thing is, today internet you can get down anything, everything. You can learn tons of things. Some not clear here, some word you cannot clear. Look, go to your phone and just search it in Google. It comes up so beautiful. So things have been so nice now for your generation. What can I tell? Okay. Then Node.js also assume that you have huge amount of memory at disposal because your application will run on real physical memory. You need a lot of them. And OS takes a big chunk of this also. Okay? And you can also configure, okay, with a considerable less memory. Depending on what to, sometimes they essentially push up and down, okay, quickly, and quite often the speed of the operation is slower than your large servers. Though it's a server OS architecture, when it comes to your IoT level, it's still slow, not that fast. Okay? And there are other web server offerings nowadays actually, which are alternative to Node.js. You can see Ruby, all these things are new ones, and more popular one is actually Python. Python is easy to learn, easy to use. Container OS architecture, this is actually most modern now. Container OS architecture. What is a container? It's a full-fledged, standalone, portable, executable package of software, which includes the code, your runtime system tools, libraries, and settings, everything together. Okay? It itself is a processor, hardware, software kind of things together. Okay? And that's the new line of systems, okay? Softwares, OS, let's call that OS. Okay? Use of concept container. Container is very popular now. It is still in, it has been there for last 6-7 years so actually, and it will be very popular going forward. Okay? And by designing this container, you can call this as a tool. You can call many things actually. It's a runtime system tools. Okay? It has its own library, it has its own settings, you can change. Okay? It provides actually a development environment also to some extent in a side way. And they are user lightweight, and you can have also some kind of OS virtualization, but entire OS is not virtualized. The reason is you are already packaging it there. So you are already putting a constant, you cannot put constant two ways. So what it does, the container is, okay, why container is more and more attractive? This is the reason. The containers isolate applications from one another and underlying OS infrastructure while providing an added layer of protections. Let me discuss this, what is going on, what it does. Okay? If you remember the conventional system, we have OS and applications talk to OS. There are two levels of OS. One is system level, one is user level. In system level is essentially you cannot touch. And system level OS, what it does, it ensures that user 1 does not step into user 2's application, program, code, anything. Okay? That way you can protect the virtual memory concept. All those things, idea is to protect individual users' interest. Now same concept here in the IoT level, container level, that OS is provide that the OS infrastructure provides have been designed such a that the applications, the many applications will be there, they will not step into each other. And container idea, approach of designing OS also does that. Okay, so that you can say is another layer of protection for applications. Okay, it's quite popular. We use that in Raspberry Pis, but it needs few gigabytes of memory. So it shows, you can see here, many apps are here. Okay, container manager is here, host OS is here, infrastructure is here, and this together we call it actually container. You can have actually multiple containers. Okay. Observations and trends. Selection of software architect depends on many things, but most important thing is power. Okay. Anything you design for IoT which consume less power is always preferable. Okay. Then availability of inexpensive off-the-shelf hardware is driving the industry towards overly capable IoT devices. Okay, so it's not that we're getting some device is very capable, then think it, do you need it really? Or just use whatever you need, it needed actually. And software development for our device is similar to classic embedded system development, but all that we discussed also falling into actions. Okay. Then in coming few years, most people are using container virtualization technology. Okay. Now, edge computing will be playing increasing role with more capability. That way, most of the computation can be handled at a low, decision can be handled at low level, and you don't have to make the traffic, data traffic between your gateway to the cloud very busy. And each time you move data, it takes a lot of time. Sometimes real-time thing cannot happen. And another thing is, once you take your data to cloud, your security privacy also is compromised. Can be compromised, not necessarily will be compromised, but can be compromised. Okay? So these are few things, and most important thing we have not discussed it, interoperability. Okay? That is still challenge in general IoT, because that's obvious. Okay, you should not be surprised why it is so, because at this point of time our architecture is not standardized. OS is being standardized, but OS cannot work independently without conforming architecture. So which means when you try to build developed system, then your architecture is not stable. OS may be partly stable. When you put together, uncertainty increases. Okay? So interoperability means you develop a new processor today, a new protocol today. I take it. Can I use it in every environment, every ecosystem? I cannot. So interoperability is a situation when you are successful build a product, take it to any ecosystem, IoT ecosystem I mean IoT ecosystem, it is going to work. That is a challenge at this point of time. It will take a while to do that. Okay. Any questions so far? Okay. Yeah, please. TinyOS, okay, I have material on Tiny. There are two things, TinyOS, TinyML. TinyOS is one thing that is being used. Now, yeah, it can be, yes. TinyOS is used by Raspberry Pi also, it's a full-fledged. It is a crippled but full-fledged, TinyOS. Yes. So they are, say, when you try to get any OS, try to cut piece by piece, is reducing things. Okay. So when you optimize, everything depends on what you need actually. Full-fledged is again is very confusing word in the sense depending what you need. Okay, that you don't have to carry a legacy OS for everything.
All these AWS and all, they sell containers.
Okay, AWS, they are platforms.
So they sell containers.
Yeah, you can actually go to those platforms and get anything you want. They kind of just like you go to a mall, they sold everything there.
Each one is like a container.
Yeah.
You can have 10 containers.
Yeah. Even you don't have to have a FPGA lab yourself, because you can actually rent the FPGAs on cloud, Google Cloud or Amazon Cloud. Same thing. Everything is same. The only thing is time taken to go there and come back. Yeah. Now, interoperability is a challenge, still a challenge. It takes a while to handle that. Okay. Now we still away from programmable world standards, but we'll be there. Okay. Now programming modes for IoTs. Programming models are basically you can program at low level or high level. Low level means you work in a very abstraction of hardware. that enhance flexibility. How? How in abstraction hardware enhance flexibility? Because when you have abstraction, you have choice to expand it. Okay? You can choose to put more hardware there because it's abstraction, right? Okay? That flexibility is in terms of giving more, pushing more hardware for more functionality. That's that in that way. Okay? And quite often it's more reliable when dynamic reprogramming is concerned. What is dynamic reprogramming? Suppose you are a mobile entity, you are moving. Okay? You must have heard from mobile communication protocols, right? How the hands off, all those things are there, right? Now you are at one position, you are moving to another position, you need some programming ability, and when you go to one to another, you may face actually an enhanced capability over there. So you can always add and subtract. Sometimes you can have a, if you are using container, for example, okay, then you can actually give more apps, more number of apps, not more apps, more number of apps into that. And you can also have multiple OS. You can have create container 1, container 2, container 3. Not necessarily, they're all similar containers. There are multiple type of containers, you can access that. So that also gives flexibility. You can jump from one to another, okay, in that sense. In the high level, what happens? It takes the application-centric view rather than platform-centric view. The previous one we talked is more like platform, but high level, you can use certain applications, large applications, which may be running on a server over there, okay? And quite often, if you have a large IoT network, you can control them at a very group level so that one control can affect so many nodes as a group, and you can hierarchically apply that techniques to have a huge group controlled by a single command. Okay? Now, the programming model, that approach, okay, also drive the performance of OS. Okay? Now, this all depends again the developer's view, which we'll talk soon actually, how developer is going to use a platform or a framework or methods to build the OS. Okay? It will basically from next slide I believe it will start. Typically, operating systems for IoT, they can have multiple programming models. Okay? And mostly used by event-driven and multi-threading. What is event-driven and what is multi-threading? Multi-threading you know pretty much, okay? Event-driven may be new if you are not done. I think you are asking something like event. Event-driven is, okay. The event is, it may be not same thing to when clear to everybody. Event is a typical action in particular environment. Okay? You can have a piece of code to be executed if ecosystem is A. Example, suppose I am dealing with speech recognition. Somebody is speaking. That happens when an event for me or for the application. It's event. It's a specific activity. It starts at time A, ends at time B. Doesn't continue all the time. Piece by piece. Event. Event driven is when event takes place, then action takes place accordingly. So action is driven by the event. Okay, that's event driven scenarios. Okay. Now, yeah, so multi-threading, multiple programs, codes being executed simultaneously. Okay. Challenge limitation faced, again we have same challenges still persisting. I always say security and privacy is a huge issue for smart IoTs. Reliable communication, it is improving because each generation accommodates more responsibility, solves problem challenges. Power consumption is always consuming more if you go for the higher order of events as well as devices. You consume more bandwidth. That's how the 5G is helping. Okay. Then interoperability still problem. It was problem since last lecture and still problem. So those are the typical things will be there. Let's get into this one. Okay, we may take about 30 minutes or so to that. Okay, yeah. This is for the developer point of view. You are going to be developer anyway because either you work academia or industry. Sometime you will be a developer. Okay, we call that as a system of systems. It has many subsystems. Okay, and when we talk about developer's view, let's talk about the development products. The classes of development products. The classes of development products are methodologies, framework, platform, and tools. 4 things: methodology, framework, platform, and tools. To many of you, this seems to be similar, and I won't blame you. Anybody can be confused to begin with, okay? But they have subtle differences that we're going to talk in the next 20-30 minutes. Okay? Now, in any IoT system you want to develop, you have to take help of these 4. 1 or 2 of these. Sometimes just tool is enough, sometimes platform is enough, sometimes framework is enough, or framework platform together, framework tools together. That way you can develop the product. Okay? So we need to understand the definition of each of these terms. Then at the same time, because you are handling engineering product, to develop engineering products, you will also need to know what are the features really matters to me in IoT domain. Smartness, autonomy, scalability, and interoperability. See, again, interoperability is coming here too. Okay? So we have got 4 development products. Development products means if I am a developer, which products I should look into to start my development, and how can I use it, what it can do for me. If you don't understand, okay, it's kind of difficult for you to do things. It's just like, in anything you start, you need to have some knowledge, some good information, some quality information so that you can start. Even preparing your final exam, you should know how to start. Okay? Same here, we need to know how to start, where to start. Only if we know what is this, what it can do for me, what that can do for me, and what is the relationship between them. We'll talk that. Then at the same time, you have to evaluate them. You have to see what I'm looking for. Okay? Do I look for smartness? If I do this way, can I build smartness? Is autonomy important for me? What is scalability is involved there? So all these features also we'll talk. Okay? Now, to address all this question, there are 3 questions here. Okay? There are 3 questions here. First one is, how does one choose the most suitable class of development product for IoT system engineering? You are developing an IoT system, you have got 4 classes of development products. So how does you know, or how to choose one you think that's most suitable for you? Is that clear? Then second one is, how does one choose a particular solution for IoT systems engineering from given class of products? Suppose you start with a platform. Sometimes you have a platform, don't have everything. They're products. Then how does one choose a particular solution if you have one product? Now, these are major challenges, or major features. The major features for IoT systems, subsystems. One is operational independence. What it means? A system having many subsystems. Okay? Now, each subsystem, when putting together, they build many subsystems put together, building system. Now, you expect that the behavior of a subsystem in a system should be remaining as it is when that subsystem is detached from the entire system. Make sense? System of subsystems is behaving certain way. You take the subsystem away and make it independent. It's still supposed to behave the same way. Intrinsic behavior should not change. Okay? Second one is managerial independence. Similar things. Each subsystem could have self-control and based on the policies. Third one is evolutionary development. What it means? It means a subsystem can evolve independently. Okay? Then fourth one is geographical distribution. It's about large scalability, large areas. Okay? Then emergent behavior. That is a new, not accidental, new behavior. If you have got dynamic system, system is changing, and varieties of hardware, we can call the subsystem, OS, software, okay? A moving or changing scenario and changing hardware, when they combine or they interact, you can get a new behavior which is called emerging behavior. New product could be showing off. The first two features, okay, they are mandatory for IoTs and others are optional. So that 2 plus any 1, 2 here, they can make a nice system design. This is a kind of analytical strategy for system of systems. You started thinking, first you have to find the context. Because you are a developer, you know, you are going to design a product which needs more flexibility, or it is easy to implement, or it is needed for a large corporate or a small startup. What are the expertise you have to do that? So these are kind of context you will be basically making your own assessment as input, where you stand, what you need. Then you come to the feature world. There you will be using any of this anyway, but at the same time you also don't ignore that the purpose of your feature, why you need that. Then life cycle support, which means I develop a product, should I leave it there or I should have a way that will continue when it goes change from version 1 to version 2, version 3, version 4, I maintain it such a way that it is always backward compatible. Third one is origin and license. Third of the origin license. Where I start from, what I have, how far I have to move. Then licenses, am I going to make it open source, everybody can use it, or is it proprietary? So those are few things you definitely look into, and accordingly your context and features can help you to move into platform, to framework, all those things. Then these are the critical features we will be discussing, that any framework we choose, any platform we choose, they will be capable of handling these features. They should be able to support scalability, they should provide the smartness, and they should be able to progress or evolve automatically, and critically they have to be interoperability as much as possible. We'll talk definition for all the 4 first, then we go from there. Now, the critical concept of methodology. Okay? Definition is very simple. I can put in 2 words so that it's easy for you to remember. Okay? A specific collection of guidelines, practices, methods, and documents, okay, to approach a specific problem. In 2 words, you can say specific guidelines for specific problems. Okay, I need this specific, nothing more or less, this much. This is my specific problem, then I need specific guidelines for that. That is your, then you need methodology. It makes life easy. Okay, makes life easy. No confusion. And it's highly prescriptive, okay, and it always have predefined steps because it is specific. And each step have details how to do it, when to do it, and what step to take one after other. It's just like, I call this actually cooking recipe. Cooking recipe is you want to cook some dishes. Then you have these ingredients. You are specific, I'll do this, sambar today. Then you have all these ingredients. And your mom or grandmom has told you to do this process, you follow these things. And you follow that. You're not going to be wrong. You'll be, as long as you follow the steps, you'll repeat that. Repeatability is guaranteed. Taste is guaranteed. Okay? The same thing here. Okay? Same thing here. Specific collects guidelines for specific problem and follow that. When to add sambar powder, okay? How long to boil the water. So all these questions are there, then you are not going to wrong. And methodologies can from qualitative to quantitative solutions too. And typically it's multidisciplinary and anybody can do that in isolated fashion. Okay? So you know what's methodology, recipes. So if you remember that, it will be easier to follow in the future also. It's a fixed guidelines for fixed problems like recipe, done. Then second one is framework. Okay? What is a framework? Same way, simple way to know is general guidelines for similar problems. General guidelines for similar problems. So you are addressing more problems that are similar in nature. Okay? Rasam, sambar, another similar dish. They are similar things. They are not same. They are not specific, but similar. They need water and powder. Okay? So in IoT, we have similar scenarios. Okay? Now, when you think of similar problems, you are covering a large area, much bigger than before. Okay? And it provides solid foundation. You also get solid foundation because since you have similar problems, your problem will be one among those or close to that. Okay? So you are likely to get some solution for you and solid foundation to start with. Okay? And this approach, this framework people develop, we'll talk about that more also later. This framework, this is looking like, this is IoT framework. You have many type of devices, homogeneous, heterogeneous devices. You have got two possibilities. Sometimes use cell towers or some Wi-Fi. You have also using common cloud, having server, storage, everything. And devices, users could be, apps and users are this side. So you can put any path, anywhere, you get a new, the similar things can be deployed. Okay? Now, this could be either open source or proprietary. I have named actually about 1, 2, 3, 4, 5, 6, 7, 8, 9. So first 5 or 6, 1, 2, 3, 4, 5, they are actually open source. The last 4, they are proprietary. Third one is platform. What is platform? We learn methodology. Do you see that methodology is not same as framework? But without knowing this, you think, oh, they are similar. Okay? But they are not same. Same thing, platform is not same. Platform, framework, many times before we study this thing, keep confusing. But platform is, look at platform, what it says. A collection of both reusable hardware and software components constituting operating environment upon which a system can be engineered in compliance with certain underlying principles. Okay? This is definitions told that. Okay? In my words, I look at it a little bit, they all satisfied with these lines. Okay? Essentially, platform is a framework, a special framework. Think that way. You know methodology, you know framework. Now, platform is a framework. First, accept that. But not that the framework. It's a typical framework scenario with a difference. This framework is not silly like the previous one, but it integrates diverse devices, which was not done in the regular framework, basic framework. Okay? First, I accept the framework, so that it will be easier for me to digest. Then, next I say integrate diverse devices and application softwares, which are essentially talking through internets and the real-time data transfers. Look at the picture, to give you more clarity. Now, you have IoT management platform. You have connectivity platforms. You have data management platforms, application enabling platforms, analytics platforms, vertical special platforms. So what you see here, you have seen so many platforms. They are platforms, not framework. Framework is going to integrate them. See the difference now? Framework is going to integrate them. Now, choose any one of that. Let's take connectivity platform. What exactly we do here? You know that in previous one we say, okay, sometime I want to connect device or devices using Bluetooth, using Wi-Fi. So it gives me option to choose one out of many. Then data management platform. There are several technology, several ways, algorithms, approaches to do data management. I can choose one of the few. Out of device management platforms. Then application. So each platform provides many opportunities, multiple opportunities, that each one is unique. Then you choose one of them, or a couple of them here, and put them together in the framework. Okay? Then you got actually easier to design. You have methodology, you have framework. Now platform, you are using platform, choose what you need. The menu is here. You choose them. You may not choose everything also, depending on need. In worst case, you need each of them, some varieties from all, or maybe few of them, depending on need, and put on the framework to move on. Okay? Then tools. Tools is different. Tools is actually always in kind of a software. They are tangible software artifacts that more or less, artifact means something you build, human builds. You build it. A module of software is an artifact. Okay? Now, more or less automatically, so tools essentially is a software. First of all, accept. Tool is not hardware, it's a software. Have you done simulation yourself? Must have done some simulators in life. Your simulator is a tool, a software tool. Okay? Now, same thing here, we have softwares. And this software also sometimes grow itself. It can develop things automatically. And they do perform specific operations using some rules. Modeling, what's the meaning of model? What is a model? Model literal means rules. Model and rule are same thing. Okay? Then a software product, okay, which has capability to operate in automatic, provide an automation, rather I should put that way. Okay? Then they can follow rule so that you can implement your product or test a hardware, okay, or test a software, or test a system, okay, and you can also verify the process. So this tool has a lot of scope when it comes to integration, testing, okay, and using software as entity to show up. And tool also is an environment for developer to build IoT applications using a range of programming languages. Okay? So if you look at that, there are so many tools available for app development, starting from Android, Arduino to so many things. Okay? So we learn 4 different concepts today, which are going to be handful for developers, starting from methods, methodology, to framework, platform, and tools. Is that clear? Okay. If it's not clear, don't worry. You can read it, it will be clear. Okay? Later. Then look at the relationship. Okay? We have 2-3 slides left, possibly. Okay? We have 1 or under 10 minutes, maybe 5-10 minutes. Okay? Yeah. Now, what is the relationship among these 4 products? Methodology offers strict principle of and practices. Methodology offers strict principle and practices, while framework provides looser development guidelines because for the similar things. So that is much looser than this. It's very strict. Mother's recipe, it can't be violated. But developers get actually loose guidelines so that more innovation is possible, more creativity is possible. Okay? And sometimes you can bring tools to build creativity. Okay? So you start with methodology, depending on requirement. If it's very strict, small, low-hanging, you can use methods and get things done. If you want more flexibility, you want to start somewhere, and frameworks are available, find out which one is more close to yours and take that, buy that. Okay? So that you can have more room to upgrade. Now, in case of methodology, your results you get is very consistent, whereas results in this framework will be some inconsistency could be there because the reason you know now. Okay? Then the results obtained from application of methodology or framework, they may vary depending on the experts, how good you are doing that. Okay? So that the former is better suited for large-scale organizations. Why? Why methodology is suitable for large organizations? Anybody can tell me? When you have more people, what they can do? They can sometimes make more nonsense things, right? Given freedom, they can jump here and there like monkeys, right? If methods giving a do this, nothing else, to get constant result, to get things done on time, that's the best thing, so that people will not mess with it. As simple as that. Okay? The guidelines provided by methodology frameworks, both the support platforms. Now you see how are coming around. Okay? So any guidelines you get methodology and framework, the support platform, because you are taking platform and integrating with framework. So a framework exploits features provided by platforms. Okay? Next is a framework is more like a facilitator than a complete solution, like a platform. A platform can be just in one area, it knows what to do in that area, finish. But if you want to integrate few things to get a bigger task, a framework is the best to start and connect those. Basically you need both framework and platforms. Framework facilitates multiple platforms when you put them together. And all control flows are already there in the framework. But you don't see that in the toolkit. Toolkit has no flowchart. Maybe tiny flowchart inside, but toolkit is like, no, you can go this way, that way, random movements. But in small way, they are like methodologies, very small ways, but largely you can find they are kind of more open access things. You can move here and there so that you can choose this what you need it. Okay, the pieces. So I would say tool has got high granularity, whereas platform and the framework has got low granularity. Here an example, you can understand what is going on here. Now we have got 4 items here: methodology, framework, platform, and tool. This way, some features. Remember the features we're talking in one of the slides? Distance to implementation, flexibility, result consistency, organization size, expertise needed. So we'll compare them along these features. Okay? So this table 1 has got all the products, we call it development products. This side, the features. Do you see any relation? Do you feel about these features? Say, distance to implementation. Do you care about this particular feature? You do care, because if I have to invest money and time, I should better know that I should be able to implement quickly. So if you are using tool, distance to implementation is low. Whereas if you are using framework, distance to implement is high. Do you understand the difference? If something you are using tool is very clean directions, that can allow you to do automatic process, software, take the input variables, does computation, gives the potential output. Whereas you start with a framework with similar high-level things, it takes more time, it will be inviting platform, inviting tools, then go there. So that's why distance to implementation is high, it takes more time. Methodology is medium, because strict guidelines. Is that clear now, this line? Question? Now, using tools and platform is faster to implement. If you start with the frameworks, it takes more time. So distance implementation means more time needed, less time needed, medium time needed. Flexibility. Framework is high flexibility. You can build creativity, whereas methodology and tools, low flexibility. We cannot do much. Whatever is given, you do that. Then result consistency, methodology high, because recipe is very straightforward. Whereas tools on this low. Why this is low? Because you might be able to traverse anywhere, with no strict movement is given to you. Again, organization, any organization can do this, use this. Methodology large. This is medium and small can use this framework. Expertise needed. High, because framework needs more insight to bring platforms, bring tools. So high. If you are good in doing something, use this. Tools, low expertise. Many people, the companies hire, fast hire. You know where they go? Companies hire M.Tech students, B.Tech students, take them. So let's say Intel, for example, is hiring. Where will put you? They'll put you in testing. Easy thing. First appointment, test engineer. They don't do anything. They only do what I was told them to do. Press this switch, press that switch. Click it, click it, click it. Test it. Okay? That's why it is very low. You don't need much expertise, but you gain experience. Go to platform, medium. Then slowly, after 2-3 years, you are here. Okay? Now, answer to a question. I mean, we have 3 questions, right? In the beginning, 3 questions. So, first 2 questions answered here. how does one choose the most appropriate class of development product? That was question 1. Answer is, there is no golden rule, but the features reported in table 1, just last table, so that degree of flexibility, distance to implement, result consistency, organizational working, expertise needed. Okay? All these provide useful insight or empirical guidelines to identify most appropriate class of development product to start with. Okay? Then, second question, how does one choose a particular solution for IoT systems engineering from given class of products? Repeat, how does one choose a particular solution for IoT system engineering, basically developing IoT system, given class of products, given, suppose a given methodology, given framework, and so on. How do you choose a particular solution? Answer is a similar answer, like it depends on its own features. Depends on its own features. What you are looking at, purpose for life, origin, licensing, and also your target features, like all those 4 features, interoperability, smartness, scalability, autonomy. Okay? That figure we started with actually. Then according to these features, the next table, we have the table here, I don't know. Maybe I have taken off, see? No, it's not there actually. I have taken out actually lunch break. Okay. So the table 2 is another list of table. It shows the features. Again, taken all those products, it shows. Now, what it does actually, it says which stage you are going to use it. Development stage or integration stage or service stage or algorithmic stage. What stage you are in project. And depending on that, what looking for? Looking for flexibility or looking for life cycle? What exactly looking for? So you basically, you have to find a cross section of this and this for products. Okay? So what you saw, you have got 4 basic features: interoperability, smartness, scalability, autonomy. You have 4 products: methodologies, framework, platform, and tools. Okay? Now, if you want to find the relevance feature with each product, you take each one, find out how they could be built into this, or whether it's possible or not, or what matters out of this to that. So we had an old set of slides. Under methodology, we have got 4 slides, each one dedicated to these features. Then 4 slides based on this for framework. 4 more slides for platform. 4 slides for tools. The 16 slides I have removed. I can put it back so that you can read it at leisurely. Okay? The challenges, the third question was challenge. Which are the well-established practices and open challenges in IoT system engineering from developers' viewpoint? Well, the cross-cutting exploitation of model-driven engineering. Model-driven engineering means rule-based designs, component-based development. So the cross-cutting exploration, you have to basically explore considering the rules, consider development, component-based development. Suppose you have this component to design something, that will be in the criteria in mind. Architecture reference model, 3-layer, 4-layer, that we discuss morning. Then whether you are going to use service built in the cloud computing solutions, you consider all these things, okay, and try to come up with solution, essentially. So, but that's a challenge, because when you try to integrate, try to segregate, or sometimes try to remove few things from many, it's not always easy. We call that kind of NP-complete problems. Okay? So for IoT methodology, framework, platform, tools, you find the relationship that we saw and choose the one. That's the challenge here. So at conclusion, the second part actually mostly is the landscape of a development product for engineering IoT system is wide, and new ones continue to emerge as a new technology is coming up. The practitioners who want to approach the world of development, they might face difficulties in comprehending all these things, selecting. That's part of the challenge we discussed last slide. Okay? So that is a steep barrier for someone to start without expertise. Been conducted, development products and methodology is part of the survey. The paper that I referred here, I'm talking about that paper. So somebody can look at this and address that. Then the output of this article, along with all the analysis been done in this particular paper, okay, provides a lot of directions, tons of directions actually. They're all open. So they're all helpful for current and future IoT developments. Okay. Questions, please. Yeah, I know it's pretty abstract and it's very difficult to find a question unless there's some definition you couldn't follow. Other than that, there's a lot of reading though. Reading materials are there. This paper is a pretty good paper in terms of clarifying the difference between all those products and which one to be used and how to use it, as we discussed. Yeah. Thank you very much. If your question comes up tonight, you can tell me tomorrow. I'm here. Okay, thank you very much. Yeah. Thanks. Huh?